Good afternoon, everyone. My name is Kushalanai Dr. Ramesh, and today I'll be presenting the outcome of our group assignment meeting held on 11th of June 2025. The meeting took place at College Kadiaman Campus Pago from 3 to 5 p.m. Let me talk and walk through the agenda and action that we have taken. The first item discussed was the understanding of the task scenario. All group members, myself, Pavitra, Lavanya, and Vishalini, ensured that we are clearly understood the task and successfully documented the midnight meetings. Next, we proceed with the appointment of specific activities. Each member was assigned as a student label, myself as student A, Paitra as student B, Lavanya as student C, and Mishalini as student D. We each took on specific responsibilities for our parts of the assignments. My tasks include preparing for the group meeting and helping to identify the equation of the line using a simple linear regression. Pavitra, a student C, she will be handling the data collection that includes interpreting the slopes and intercepts and ensuring all necessary data is recorded accurately. Lavanya, a student C, that she is responsible for plotting the graph and analyze the effect of the exam score and study time and creating the fila table. Mishalini, as student D, will be analyze the data and leading the discussion on how study time affect academic performance. She will be summarizing our findings and conclusions. In summary, each team member is fully aware of their responsibilities. Thank you.
Good afternoon, everyone. My name is Lavanya Anabrampan Patpanathan, and now I'm going to explain the fila table of our report. This table helped us structure our thoughts and stay focused throughout our investigation. Firstly, under facts, we highlighted that we knew that there might be a relationship between how much time students spend studying and how well they perform in exams. We gathered real data from Year 1 applied science students using a Google form, aiming to answer a simple yet important question: does studying more really lead to better scores? Our ideas section, however, reflected our hypothesis. We believed that consistent studying would improve understanding and naturally exam scores. But we also considered that other factors like stress, health, and distraction might interfere. Thirdly, in the learning issues part, we raised questions like how many hours of study actually make a difference? Are there other hidden factors impacting performance? And how can we design a survey that captures this data accurately? To answer these questions, we moved to the action plan. We designed the go- Firstly, we designed the Google form. Second, we created a scatter graph. We also referred to books and journal articles, and we used regression analysis to find trends.
Hi, my name is Pavitra, and I will be explaining about the results. Based on the survey that we did, we have used Google Form to get the data from those students. So, in this table, I've created the table about study time versus exam scores that has been achieved by statistics student. Where the study time we have less than 2 hours, 2 to 4 hours, 5 to 7 hours, 8 to 10 hours, and more than 10 hours. And in total, we got 22 responses. And here's the table that shows the study time and exam scores that has been achieved by statistics student in table form. Here is another table showing the study time versus average exam score that has been achieved by statistics students. So now let's move on to the hypothesis testing procedures. So here, in this analysis, we want to test if there is any correlation between study time and exam scores. So first, we have to set up our hypothesis. So here we set up null hypothesis and alternative hypothesis, where null hypothesis means there is no significant correlation between study time and exam score. Meanwhile, alternative hypothesis means there is a significant correlation between study time and exam score. So we choose Spearman's rank correlation because our data here is ordinal, which means it's grouped into categories like less than 1 hour, 1 to 2 hours, and so on. So it's not an exact number. And this method also used when we are testing for monotonic relationship, not necessarily straight line or linear ones. So in the table there shown in the table shown, I have listed the study time, exam scores, and also the assigned rank to each study time and the exam scores. Then we calculated the difference in ranks and squared those differences because these values are needed to calculate the Spearman's correlation coefficient. As we can see in the table shown, we have those values which we use to calculate which we use to calculate using the Spearman's correlation coefficient method. Okay, next we have to sum up the d square, where we will get here is 2125, and we will get n is equals to 22, which is the number of responses, number of students who responses. Okay, and then we have to substitute both values into our Spearman rank correlation method formula, which is p equals to 1 minus 6 times with d square, sum of d square, divided with n in a bracket n square minus 1, and here we will get negative 0.20. So we will get p equals to negative 0.20, indicating a weak negative correlation. Therefore, using a significant level of a equals to 0.05 and n equals to 22, we will get a critical value plus minus 0.423. Since modulus P is equals to 0.20, which is less than 0.423, the result is not statistically significant. So here we fail to reject the null hypothesis because no significant relationship between the study time group and also the exam scores.
Now, for my second part, I'm going to explain about the graph that we plotted, which is about the study time versus average exam scores. We were able to plot this graph by grouping our data into 5 categories, which is less than 2 hours, 2 to 4 hours, 5 to 7 hours, 8 to 10 hours, and lastly, more than 10 hours. So here's what the graph showed. There's a general upward trend, which is as study time increases, average exam scores also tend to rise. For example, students who studied around 2 to 4 hours had average scores around 8.3, while those who studied 8 to 10 hours scored around 9.0 on average. But interestingly, those who studied more than 10 hours did not show much improvement. Their scores were only around 9.4. This suggests that more study time doesn't always equal better results, especially if that time isn't used effectively. So, in summary, our analysis tells us that there's a weak but positive relationship between study time and academic performance. Moderate study durations, like 5 to 10 hours, seem most effective, but beyond that, quality matters more than quantity. Thank you. That was all from me. I hope this gives you a clear insight into how we approach the data and what we discovered.
So let's move on to the analysis and conclusion. Here I have created the table 3, where there is study time, midpoint, and also average exam score, which will be used to the calculation after this. I have assigned midpoint as x because we use study time here as class intervals, where there is less than 2 hours, 2 till 4 hours, and so on. So we will be finding midpoint to the calculation after this.
Now let's move on to the analysis and conclusion of our data. First, we calculated the sum of x value and we will get 30. Next, we added all the y value equals to 43. Then we calculate the sum of product of each x and y pair. We will get 267.5. And we also calculated yx square equals to 248 and y square equals to 370.98. With this value, we use the formula for Pearson correlation coefficient. We will get R equals to 1.060. Using that, we calculated the slope B1 of the regression line and we will get 1.51.92. Then we found the y-intercept B0 using using, and we will get negative 0.5152. So the final equation of the regression line is y equals to 1.5192x minus 0.5152. This equation shows the relationship between our variable and helps us to predict y based on x.
Okay, now let's go into discussion, which is how study time affects the academic performance. Based on our analysis, we found that study time has a positive but weak correlation with academic performance. The slope from the linear regression was about 1.52, means for extra hour of studying, the average exam score increased slightly. However, this effect is not strong. This tells us that while studying more can help, it doesn't guarantee better results. Other facts, likely how you study, your focus, your environment, stress levels, and your personal learning style likely plays a bigger role. From the scatter plot, we saw the scores generally improve between 2 to 10 hours of study. But students who studied more than 10 hours didn't really score higher. But this could mean that studying too much might lead to stress or less effective learning. So now let's move on into the summary. So firstly, there is a positive linear relationship between the study time and academic performance. The correlation is weak, which is the slope is equals to 1.5192. So the study time alone does not strongly determine the exam result. However, other factors like focus, environment, and techniques are crucial. And the analysis suggests a moderate and a consistent study hours, which is like between 5 to 10 hours, are linked to get a better score, aligning with literature. So to improve academic outcome, students should combine efficient study techniques like spaced repetition or self-testing with a sufficient time investment. And lastly, future studies with larger samples and more variables, for example, sleep, learning style, could provide a clear picture.